What would happen if someone tried to seal a volcano with cement? A volcano erupts. Lava pours down the mountainside, hot, unstoppable. Thick smoke fills the entire sky. People panic, cars race down the highway, sirens blare, breaking news floods every screen, and then, someone in the comments writes something. Why not just cement the top so it stops erupting? Cement the volcano shut. Simple. Just cover it and the problem is solved, right? But is it really that easy? Can a volcano actually be stopped with just cement? Let's find out. First, you need to understand how a volcano actually works. Not all eruptions are the same. Some are slow, some are catastrophic. And the difference matters enormously. Volcanoes like Mayon volcano in the Philippines sometimes release lava through what is called an effusive eruption. These are eruptions that are not sudden, not extremely violent, just slow and steady. In this type of eruption, lava slowly flows from the mouth of the volcano. It moves down the slopes of the mountain, gradually, predictably. This usually happens when magma continuously rises from underground and finds a clear path to the surface. During mild activity like this, you see lava flows, ash emissions, and sometimes small rocks falling around the crater. It is mild, but it is still dangerous, especially for communities living inside the danger zone. The good news is, there is usually enough time for authorities to evacuate people, because it is not an instant explosion. There is a warning window. The more severe and far more dangerous type of eruption is called an explosive eruption. In this case, pressure builds up inside the volcano. Thick and viscous magma blocks the path of gas. The gas has nowhere to go. Pressure builds and builds until it cannot be contained anymore. And then it explodes, violently, without mercy. In this type of eruption, pyroclastic density currents can occur. These are clouds of ash, rock, and gas moving at hundreds of kilometers per hour. Extremely hot, extremely fast, completely deadly. This is one of the most dangerous natural phenomena on Earth. It can burn everything in its path. It can bury entire towns in minutes. There will also be heavy ashfall, thick layers of ash falling from the sky, heavy enough to collapse rooftops, dense enough to make breathing nearly impossible. And then there is lahar, a rushing torrent of mud, a mixture of volcanic ash and rainwater. It forms when rain or a typhoon hits after an eruption, and it moves like a wall, sweeping away houses, roads, bridges, everything in its path. Now here is something important. The exact date and time of an eruption cannot be precisely predicted, but it is also never completely sudden. Before a volcano erupts, there are almost always warning signs. An increase in volcanic earthquakes beneath the ground. The volcano physically rising or swelling, called ground deformation, a rise in sulfur dioxide gas emissions, and changes in heat or temperature around the crater. Scientists watch for all of these every single day. Now, even though it might sound funny, can cementing a volcano actually work? Let's do the math. Mayon volcano stands at approximately 2,463 meters tall. It is an active stratovolcano, one of the most perfectly shaped in the world. Its crater is estimated to be about 200 meters wide. Now imagine covering that crater with concrete, 10 meters thick, like placing a heavy lid on an enormous circular hole. To do that, you would need approximately 314,000 cubic meters of concrete. That is not a small amount. That is an almost incomprehensible amount. In standard concrete production, every cubic meter uses roughly 7 to 8 40-kilogram bags of cement. That works out to approximately 2.3 million bags of cement. A single bag of cement typically costs around $3 to $5. If we use $4 per bag when buying in bulk, the cost of cement alone reaches nearly $9 million for the cement. Just the cement. But of course, cement is only part of concrete. You also need sand, gravel, water, steel reinforcement, heavy machinery, helicopters or special transport to carry everything up the mountain, and the wages of engineers and construction workers. In large construction projects, cement typically makes up only about 25 to 35% of the total cost. Add everything together, the total cost could reach or exceed $27 million to $36 million just to cover the top of the crater, not including the deeper sections inside the volcano, not including ongoing maintenance, not including the cost of failure, and for context, that is actually small compared to the billions spent on flood control infrastructure around the world every single year. So should governments just cement volcanoes instead? Let's think about whether that would even work. If we covered the mouth of the volcano with thick concrete, the first thing to understand is this: it would not stop the magma. Not even slightly. Magma rises from deep inside the earth. It operates at pressures and temperatures that are almost impossible to imagine. We are talking 700 to over 1,200 degrees Celsius, depending on the type of magma. A concrete wall means nothing to magma. It does not care. It does not slow down. It does not turn around. As magma continues to rise and gas continues to accumulate inside the volcano, it searches for the weakest point, any crack, any gap, any weakness in the rock, and it escapes through there. Or it simply cracks and destroys whatever barrier was placed above it. Magma cannot just return back down into the earth as if nothing happened. It is molten rock, originating from deep inside the earth's crust. Forces from inside the planet push it upward, continuously, relentlessly. It is not like water that can be blocked by a dam. It is more like pressure inside a sealed container that is being heated from below. Something has to give. Second reason cementing fails. A volcano continuously releases volcanic gases: sulfur dioxide, carbon dioxide, water vapor. These gases rise constantly. A cement cover cannot absorb them, cannot block them. The gases escape through cracks, gaps, and alternative pathways. They rise into the air regardless. When they spread, they cause serious breathing problems. They affect communities far from the crater, far from where anyone expected the danger to reach. Third reason, and this is the most dangerous one. If you force a concrete cover over the crater, pressure and heat continue building underneath. Nowhere to go, just building. And building until something breaks. When the pressure finally escapes, it does not escape slowly. It explodes. The accumulated gas and magma escape faster than they ever would have naturally, more violently, causing a much stronger explosion. Wider spread of ash, rock, and superheated gas. When pressure is trapped for a long time and then suddenly released all at once, the result is catastrophic. The surrounding communities face dramatically higher danger, because the eruption is now far more intense than it would have been without the concrete. In short, covering the crater does not weaken the volcano. It makes it more dangerous. Far more dangerous. Now what if we went even further? What if we tried to fill the entire inside of the volcano with cement? The cost alone would be staggering. We are talking billions of dollars. Not millions. Billions. The labor would be nearly impossible because of the height, the heat, the constant activity. But even if you somehow managed all of that, there is another massive problem. Concrete cannot harden properly inside an active volcano. Fresh concrete requires specific conditions to cure and strengthen. It needs the right temperature, the right humidity, time to set properly. Inside a volcano, the heat from magma is extreme, far beyond what ordinary concrete can handle. The concrete would not harden normally. It would crack. It would weaken. It would crumble before it ever became solid. And even if by some miracle it hardened, it still would not stop the volcano, because magma does not just come from inside the mountain. It comes from much deeper inside the earth. Even if the existing pathway is filled with concrete, new magma continues rising from below. The natural process inside the planet never stops, never pauses, never negotiates. When the magma has no path through the center, it does not give up. It causes the ground around the volcano to crack. It forms a new vent in a different location. Instead of one eruption in one place, you could end up with multiple eruptions along the side or base of the mountain. In other words, you shifted the danger. You did not eliminate it. You moved it somewhere else, possibly somewhere closer to populated areas. We currently have no technology capable of stopping or controlling an active volcano. None. Not even close. What experts actually do is not try to stop the eruption. They focus on detecting it early and preparing people to survive it. Volcanologists monitor earthquakes around the volcano. They track ground uplift. They measure volcanic gas emissions, looking for signs that an eruption is approaching. When activity increases, alert levels are raised immediately. Warnings are issued. Evacuation orders go out. People move to safety before the worst happens. That system, monitoring, warning, evacuating, has saved thousands of lives. Not concrete, not cement, not engineering. Knowledge, preparation, speed. The most effective solution is not cementing or blocking a volcano. It is early warning, proper preparation, and keeping people far away from danger zones before disaster strikes. We cannot stop a volcano. That is the truth. The Earth is more powerful than any material we have ever created, but we can reduce the damage. We can protect people. We can save lives. Through science, through vigilance, through respect for the power beneath our feet. Because the ground we stand on is alive, and it always has been.